Okay, the goals of this course are the follows. The first thing is to learn new languages quickly. There are so many programming languages in the world. How many of them do you know? Ada, Assembly, C, C++, C Sharp, COBOL, Erlang, Fortran, Fortran, Haskell, Java, JavaScript, Lisp, Make. That's another language, right? Objective-C for Apple, OCaml, Pascal, Perl, PHP, Python that you love, right? R, Ruby, Scala that we love, Scheme, Shell, Smalltalk, SQL, Visual Basic. We can name all of them, and there are so many more. So it is not likely that you learn one language and the other thoroughly with passion and time. But after taking this course, I hope that you can learn new languages quickly by understanding the core features of programming languages. The second goal of this lecture is to evaluate languages and pick the best for a given task. Among those languages that I named before, there is no single best language for everything. C is really good for system programming. It's really efficient and you can get good performance out of it, but existing C programs have many bugs and memory vulnerability because of the C features that we can discuss later. JavaScript is really cool, and that's the most widely used language for web programming. If you have a browser on your iPhone, on your smartwatch, smart TV, you can run JavaScript code. That's really cool, but it is one of the worst languages ever that we can discuss later. So depending on your task, you can evaluate different options like different programming languages, and you can pick the best one for your own task. The third one is to know when and how to design a little language. Design a little language? Design a new programming language? Isn't it for genius people, those people? Not really. You can learn what are the abstractions, how do they interact. You can think about what should be expressible and what should not be. And after this semester, I sincerely hope that you can answer these questions. And if you need, you can design a new language. One of my previous master students, he was really smart and he was a really good student, and now he's working at some game company, and now at that famous game company he's designing and developing a new programming language for game programming. It's really cool. And finally, I hope that this course helps you to understand the effects of language on thought and communication. So you may not understand what I'm talking about with this slide, but hopefully we can discuss this later over the semester. There are several approaches in programming language courses. One obvious approach is to survey various options. Like when I was an undergrad at, again, the computer science department at KAIST, we took this approach, survey approach. This week C, next week Haskell, after that Java, after that JavaScript. We can skim through different languages and different options, but you don't really learn anything. I'm sorry. But the second approach is definitional interpreter approach. One of those famous books about this approach is this, Essentials of Programming Languages by Daniel Friedman and Mitchell Wand. And this approach is to implement an interpreter for one single language from top to bottom. Yeah, it's a pretty practical approach. The third one is a rigorous approach by Benjamin Pierce. This is one of the most famous books in this programming language community called Types and Programming Languages. We call it TEPL. And you can take a look at that from these websites. And this book is really famous, and many good schools, especially in the US, like Harvard, Cornell, UPenn, they use this textbook. as a programming language course. But in our course, we are gonna have mixture of that. The programming language concepts in two ways. By using Scala, the programming language called Scala, we are going to implement various interpreters. But we do not assume that you already know Scala, so we are going to give you some time to be familiarized with this Scala programming language by asking you to do some exercises. They were used to be homework assignments, but now that we are not gonna grade them and we are not gonna, ask you to do that, you'd better do that to survive this semester. And the second one is by implementing interpreters for multiple languages, and we'd like to define languages via interpreters. I know it's not gonna be clear to you what I mean by this, but as time goes by, you're gonna see what I'm saying. Now, interpreters versus compilers. That's one of the famous questions in the interviews in either graduate school entrance exams or any kind of internship or when you find a new job. If you are saying that you studied programming languages, or if you say you took computer science course, courses, then they can ask, what are differences between interpreters and compilers? Let's see. An interpreter takes a program and produces a result. Yeah, very natural, right? It takes a program as an input and produces a result, just like a calculator or a Scala interpreter. They are really good for understanding program behaviors because when you write some code and run it, you're going to see the result right away. And it's easy to implement. What is a compiler? A compiler takes a program and produces another program. What? Are you kidding? I have a program, so I want to run it and get the result. But a compiler does not run it. It takes a program in a source programming language and produces another program in a different target language. Like GCC for C compiler, Java C as a Java compiler, and Scala C as a Scala compiler, meaning that Scala has both an interpreter and a compiler. Compilers are good for speed and they are more complex. So we may want to use an interpreter to quickly implement its behavior to see how that works, like just quick prototyping. But if you want to have long-lived programs, then you may want to have a compiler. In addition to the textbook, we have two resources. The first one is about Scala programming language. The title of the book is Programming in Scala, written by Martin Odersky, Lex Spoon, and Bill Banners. They have several versions of this textbook, and this is really awesome because Martin Odersky is the father of this language called Scala. Because our implementation language in this course is Scala, this book should be helpful to you. And the first edition is available for free online, so you may want to visit this website. The second resource is called PLAI in short, and in total, Programming Languages, Application and Interpretation. It is written by Sriram Krishnamurthy from Brown University. Again, this book is also available for free from website. So this book tells you more about programming languages in general, and this book is about the Scala programming language. So the main concept that we covered during this semester is more closer to this one, except that it does not have much about types that we are going to discuss after the midterm exam. And this one is going to be really helpful for you to do your exercises and homework and projects. So Scala, that's our implementation language. As I said, I got all my degree, especially the PhD degree at KAIST, and I moved to Harvard. I worked at Harvard University for 3 years, and then I moved to Sun Microsystems Laboratories. They were really good. They were doing really good research, and they made good projects. I think I can tell you more about that later. But I met my mentor there, Guy Steele. You're gonna see his face in a minute. And at that time, we implemented our language compiler and interpreter in various languages. And we used Java, Objective-Camel, and others, but we ended up using the Scala programming language because it's so cool. I'm going to tell you some things about Scala, and after my second lecture, the second part of today's lecture, our head TA, Jaemin, will give you a little bit about Scala. So let's see. Scala is the language. The Scala programming language is my favorite language. I have various experiences. I have quite a few experiences with multiple programming languages: C, C++, Java, JavaScript, Objective-Camel, Standard ML, and many others. But Scala is my favorite. Let's see why. Before that, we in our School of Computing, we have Professor Alfred Jung, who is on leave for some time in Germany for now. He once taught CS109 and CS206 in Scala. So he wrote some materials about Scala. He's a really good teacher. So I asked him to make this material, all his write-up available for you guys, and he was pleased to do that. So you have this resource again. Scala. It's a growable language. Scala is a shorthand for scalable language. Language that grows according to users' demands. Because different people want different things, and even a genius like Guy still cannot predict what you guys are gonna want in 2020. So we strongly believe that languages should grow. So he's Martin Odersky. Martin Odersky, the father of the Scala programming language. He was giving a lecture about the Scala programming language, and he's using Guy Steele's talk. Here's the guy, my mentor. I admire him. And he gave an awesome talk at some prestigious conference. The title of the talk was Growing a Language, Guy Steele, in 1998. I think most of you were not even born that time, right? But his talk is so awesome. Your only homework assignment, remember? Yeah, you have only one homework assignment. That's gonna be watch his video in 1998 and write an essay about it, because it's so beautiful. And Martin Odersky said that Guy's talk was an absolute piece of beauty. Can you believe that? A technical talk is an absolute piece of beauty, and I strongly agree with that. And you are gonna watch that later. Then what is Scala? Scala, let's see what it provides to you. Scala REPL. I'm going to show you REPL. REPL meaning there are for read. Read. E for evaluate. And P for print. And L for look. So you read, evaluate it, print the result, and do that again. That's REPL. So Scala REPL is like this. It's gonna show you this prompt saying, what do you want? And you type 2 times 3. Then the Scala REPL is gonna read 2 times 3, and then it evaluates 2 times 3 and prints the result 6, and do that again. And you are gonna say, I'm gonna declare an identifier whose name is A, whose value is 10. Then it's gonna say A, oh, I see, its value is 10 and its type is int. And you're gonna say, now I'm gonna introduce another name called B, whose value is 1 incremented by the value of A. Oh, what's the value of A? 10. So the value of B is 11. Now I'm sick of the value of 10. So I'd like to change the value of A. This is assignment, I hope. And say, hey, A's value is now the value of previous A and add 1. And the Scala REPL says it's an error. You are not supposed to reassign new value to a name declared as val. Ooh. It's like that. Okay. What about val and var? You're gonna see that later, and I believe that Jamie is gonna tell you more about that later. Functions. Function is the most important concept in programming languages, right? In Scala, when you define a new function, you're going to use the keyword def. Def, meaning I am defining a new function named add. It has 2 parameters named A and B. Their types are int. And this function add will take 2 integers and produces another integer. That's what it says. Scala checks types of programs at compile time. So when we call this function add with 2 numbers, then it's gonna check the arguments. Oh yeah, their types are integers, that's good. And then produce the result. So far so good? Oh, look at this. We are defining a new function named fun, F-U-N, which is not really descriptive. It's not a good name, but it takes 1 integer and it's a sequence of expressions. Add 1 to the value of A, subtract 2 from the value of A, multiply 3 to the value of A. And we are going to call the function with the argument 10, meaning A's value is going to be 10. That was the result. What's the result of calling function fun with the argument 10? What do you think? What do you think? A usual wrong answer. Yeah. Usual wrong answer is 10 plus 1 is 11. 11 minus 2 is 9. 9 times 3 is 27. That's a wrong answer. Why? Because we do not need to return statement, and we do not need to change the value of A. A's values are just what? A's value is 10. So A plus 1 is going to be 11. A minus 2 is going to be 8. 8 times 3 is going to be 30. Type inference. Previously, the add function had this return type annotation. But because Scala has type inference, you can drop the type annotation for the result value. The result type of add and the type of m, oh yeah, here too. You do not need to annotate the type of m because it can infer the type of them. The Scala programming language, the Scala compiler infers their types. But it cannot infer the types of parameters. Another different kinds of functional languages like Haskell and ML, they can even infer the types of A and B. But Scala doesn't do that because it's less ambitious. It does not infer the types of function parameter. If you want to know more about that, please check this site. So Scala is expression-oriented, and as we saw before, it does not need to return values. It does not have many statements. They are expressions. So Scala supports expression-oriented programming where expressions have values, meaning that in C or Java, these if statements are not gonna have values, but they do some actions and some store changes. But in Scala, these if are expressions. They are not statements. And the value of the result is going to be the value of this if expression. Expression-oriented programming again, the function body automatically returns the value matched to each pattern. Let's see what that means. This function called error message, it takes an input, which is an integer, and then matches the value of the parameter with different cases. Case number 1, when the value of error code is 1. Case number 2, when the value of error code is 2. Case number 3, when the value of error code is 3. If the value is 2, it matches to the second case and then returns permission denied. With all these examples, I strongly recommend you to run them. Install Scala and run the Scala repo, and then type the code and see the result. That's what you're supposed to do. Finally, I'm going to tell you some more details about good programming. The first thing is test-driven development. When I first worked at Sun Microsystems, like I told you before, one of the cool things that I learned from there was test-driven development. Start writing test cases before writing programs. Even before you type main, void main, or whatever, even before typing anything, start writing test cases. Write the simplest code you can to pass those tests. If your code doesn't do everything you want it to, write more tests and repeat. So tests are really important. And writing code and tests in tandem, meaning in parallel, meaning at the same time, that's the best practice. Tests are a great source of documentation. They are precise because they are code. They are executable because they are code, and they're always in sync with the code. Remember, if you have comments, it's not really likely that you're going to have the same code and comments. You start with nice comments, but while changing your code, fixing bugs, it's getting far from the original comments. So tests are going to be your guidance. Tests help us keep the design simple. Tests help us make incremental progress, and they protect our code. This is homework number 0 that you should do today. So it's due the first day of this fall semester. Visit the homework submission server. This is the URL, and click the register button and follow what it says, and that's it. It's really easy and simple, so you should do that just the very first day of this fall semester. That's the deadline. If you don't do that on Monday, August 30th, then you cannot take this course. This is homework number 0 due. Finally, this is the most important slide today. As I said before, cheating means F. I believe that you signed honor code from school, KAIST. It's a school level honor code. And also, if you haven't done that yet, you're gonna do that pretty soon to sign honor code from the department, School of Computing. So we have a school level honor code and department level honor code. And in addition to that, we do have CS320 rule, our own rule for this course, which is that cheating is strongly forbidden. Cheating will give you an F. I mean it. This course is really famous or notorious to give F even 1 week before the final exam if we catch cheating, no matter what reasons. Okay, please don't even think about it. This is it for the first lecture. And if you are freshman students, please drop this course and have more experiences with various programming languages and come back. Okay, have a good day.